Okay, so we looked at rounding and we looked at the place values and how with the place values in there, every digit is a count and a name. So now let's take a look at doing our basic operations with larger numbers and how that all fits together. So let's take something like 347 plus 251. Now, as we saw earlier, each of those numbers is really an abbreviation. The full form of 347 is 3 hundreds and 4 tens and 7 ones. And the full form for 251 is 2 hundreds and 5 tens and 1 1. And we mentioned earlier that each digit becomes a count and a name. We have 4 tens, 3 hundreds, 5 tens. And if you recall, when we add, we can only combine things that have the same name. So that comes right down to individual digits. This 4 tens here can only combine with these 5 tens. And those 7 ones can only combine with the 1 1. That's why when we learned how to add large numbers and to subtract large numbers, it was pounded into us. You have to line up the columns. So now that we have those columns lined up, we can go ahead and add. 3 and 2 make 5 hundreds. 4 and 5 make 9 tens, and 7 and 1 make 8 ones. So 598. Now some of you might have been looking at that and thinking something looked kind of strange. What did I do wrong? Or wrong compared to what you were taught? I went backwards, didn't I? I started on the left and I worked my way to the right. You've always been taught to go the other direction. Start on the right, start at the end, and work your way back to the beginning. Why? Well, in case you have to carry, yeah. When you run into something like 447 plus, or 347 plus 494. We start on the right and work our way back to the left because we run into this. 4 plus 7 is 11. Well, we can't have two digits in the same place. So we're going to keep the 1 and we're going to carry the first one. Then that 1 combines with the 4 to make 5. Plus 9 is 14. So again, we're going to keep the 4, carry the 1. 1 and 3 is 4, plus 4 is 8. So we get 841. Believe it or not, that process of carrying is a relatively new process. Only about 150 years old. Before that process was developed, now you don't have to write this part down because I'm never going to make you do it this way, but some of you might find it interesting. Before carrying was developed, these numbers could have been added like this. 3 plus 4 is 7. 4 plus 9 is 13, so 3, we're going to drop the 1. 7 and 4 is 11, so 1 and drop the 1. 841. You notice we get the same answer. Looks different. Takes a little bit more space, maybe a couple seconds more time, but really not that much more complicated. I didn't show you that to change the way that you add numbers. I showed you that to make a point that we've always been taught in math there's only one right way to do things. Well, there is only one right answer, but there's often a lot of different ways you can go about getting to that answer. I could show you 4 or 5 different ways of adding numbers that work every time. I'm not going to do it now because I don't want to confuse you, but it doesn't matter what your process is as long as it's a process that's going to work every time. If you guys have a different way of adding or any of the other operations from what I've shown, come talk to me and I'll take a look at it and see if it works every time. And if it does, feel free to use it. Now, I'm a realist. Looking at something like this, I know a lot of you have the calculator. You're not going to do 3-digit addition by hand if you can avoid it. On the first quiz, I think there's 6 problems I ask you to do without a calculator. Other than that, you can use your calculator on everything in this class. But if you're using the calculator, I do ask that you look at it this way. 347, well, that's closest to 300. 494, that's closest to 500. 3 and 5 makes 800. Before I punch this in the calculator, I'm going to do that estimate so I know that I'm expecting an answer close to 800. The reason why I say that is, for someone like me, I have these big sausage-like fingers. When I'm punching the calculator, it's not uncommon for something like this to happen. 347 plus 494. What happened there? Well, when I did my 494, the 9 didn't register, did it? It's not uncommon. My background before I came here, I have a little bit of background in teaching in high school, but most of my background is working in structural engineering. I'd be on a job site and sand would get in the keys of my calculator. Not uncommon to have to really grind one of the buttons to get it to register. If you're not paying attention, you write down 391 and you go with it and you pay the price for it later. Having this estimate here, knowing that it better be close to 800, keeps me from, I get 391 and it alerts me to take a look and make sure things went right. Or the other thing that might sometimes happen, 347 plus 494. What happened there? Hit an extra button. When I hit the 9, I also hit the 8. Again, fat fingers. But if I'm doing this estimate and I'm expecting 800, I know that 5,000 makes no sense. But if I'm not, if I'm just putting all my faith in the calculator and putting in buttons and writing them, crunching numbers and writing them down, that one can sneak by. So be careful. For subtraction, $357 minus $223. Now, normally I would write these out in expanded form and long form for you, but you guys get the point that each digit has a name and you can only combine things that have the same name when we add or subtract. That's why we have to line up our columns when we subtract, just like adding. So now that I have everything lined up, I can go ahead and just subtract the columns. 3 minus 2 is 1. 5 minus 2 is 3. 7 minus 3 is 4. So we get 134. Well, what did I do again? I started at the beginning and I went to the end. I started left to right. We're used to doing subtraction right to left, starting at the end and working our way back to the start. Why do we do that with subtraction? Not for carrying, but for, what's it called in subtraction? Borrowing, right? We might end up with 546 minus 397. I start at the right and I work my way back to the left in case I run into this. 6 minus 7 can't be done, so what do we have to do? Borrow from the 4. So that 4 becomes a 3. This is now a 16. Now, a lot of you may have just seen the 1. You put the 1 in front of the 6 and you go. You don't cross it off and rewrite it. That's another shortcut built onto it. Either way works fine. So 16 minus 7 is 9. 3 minus 9. Can't be done. We have to borrow. So the 5 is going to be a 4. This is now a 13. 13 minus 9 is 4, and 4 minus 3 is 1. So we get 149. Now, just like with carrying and addition, borrowing is a relatively new process. Again, you don't need to write this down because I'll never make you do it this way unless you really want to. But before borrowing was developed, one way this could have been done was 5 minus 3 is 2. 4 minus 9 can't be done, so I'm going to take from the 2. It's a 1, and this is a 14. 14 minus 9 is 5. 7 minus 6 can't be done, so I'm going to take from the 5. That's a 4, and this is 16. 16 minus 6 is 9. You notice I get to the same answer. It just looks different. Again, I can show you 3 or 4 different ways to subtract. The point is, there are different processes, there are different paths to get to the correct answer. Again, I'm a realist. I realize you're going to look at this and probably say, hey, 546, that's about 500. 397, that's about 400. 5 minus 4, I'm looking at 100. I'm expecting an answer around 100. 149 makes sense. Any questions? Okay. Let's look at multiplication. For multiplication, for this first example, at least, I am going to go ahead and write this out in its full form. 23 is 2 tens and 3 ones. 32 is 3 tens and 2 ones. When I multiply, do I need to have the same name? No, we don't. So this 2 tens here not only can be combined with the 3 tens, but it can also be combined with the 2 ones. In fact, every digit from the first number can be combined with every digit from the second number. And that's all that long multiplication is. It's an organized method of making sure every digit in the first number gets combined with every digit in the second number. So what we usually do is we start with the last digit of the bottom number. In this case, are 2 ones. And we start combining that with digits from the first number. We start at the end of the first number. 2 ones times 3 ones. Well, we combine counts. What's 2 times 3? 6. We also combine names. What's ones times ones? That's ones. Then we go to the next digit in the top number. 2 ones times 2 tens. We combine counts again. 2 times 2 is 4. Ones times tens is tens. Now we've combined this 2 ones with every digit in the top number. So we're now going to move over to this next digit. When we do that, what were we taught to do down here? Move over a spot or put a 0 in here, right? One of the two. Either leave a blank or put in a 0. The reason for that's going to become apparent in this next step. Well, I now take my 3 tens times my 3 ones. 3 times 3 is 9, but tens times ones is tens. Putting that 0 in there was just making sure that our tens line up with our other tens. Their place values stay lined up. Now we have the 3 tens times the 2 tens. Multiplying the counts, 3 times 2 is 6. Tens times tens is hundreds. And now we just combine our like place values. 6 ones and 0 is still 6. 4 tens and 9 tens is 13. So that's 3. Carry the 1. And 1 and 6 makes 700. So 736. So all those little things that you had to do when you did long multiplication are explained if you put the place values in there. You write them out in full form. Now again, I'm a realist. I realize that you have the calculator, you're probably going to use it. I would at least hope that you look at this and say, okay, 23 is about 20, 32 is about 30, 2 times 3 is 600. I'm hoping for an answer around 600. Any questions with that? Okay. I do want to take a little bit of a moment here to talk about the estimating that I've done so far. If I were adding this, all I'm doing is I'm taking it to the first digit. Since these are both, that first digit is both hundreds, it's easy to combine those. So 573 is closest to 600s, 218 is closest to 200s. When I add or subtract, first thing is I need the same name, which means these numbers here have to be in the same place value. They are, they're both hundreds. So I combine 6 and 2 to make 8. But also when I add or subtract, I keep the same name. So those are 6 and 2 are both hundreds. The 8 has to be hundreds, which means I need 2 zeros. When I add or subtract, when I have zeros at the end of the number, in other words, with rounded numbers, all I'm doing is keeping the same number of zeros. So if let's just do an estimate here. Let's say I have 800 minus 500. I'm going to do 8 minus 5 is 3, and how many zeros? 2 zeros, right? If I do 70,000 minus 20,000, what am I going to get? 7 minus 2 is 5, and I have 1, 2, 3, 4 zeros. Both of them have 4 zeros. The problem comes in when I have something like this. 3,000 plus 800. They don't have the same number of zeros, do they? So for my estimate, I have to keep the 2 zeros. 30 and 8 make 38, and I put my 2 zeros in. The reason I pointed that out is with our multiplication, it's different. I had 2,000 times 300. I can go ahead and multiply my 2 and 3 to get 6, but when I multiply, I also combine the names. Thousands times hundreds is 100,000s. Well, what's the easy way to know how many zeros to put on the end of this? Combine them. I have 3 and 2 makes 5 zeros. If I have 700 times 30,000, 7 times 3 is 21. How many zeros? 1, 2, 3, 4, 5, 6. So 21 million. Where it can be a little tricky, let's say I have 5,000 times 400. 5 times 4 is 20, right? I have 1, 2, 3, 4, 5 zeros. So is that right? Right? I have 5 zeros? No. I have to have 5 more zeros. This 0 is part of the 5 times 4 to get 20. So I have to have the 5 more zeros on the end. 2 million. So if I were dividing 8,000 divided by 200, instead of combining the zeros, here I had 3 and 2 makes 5, I'm going to cancel the zeros. There's 2 zeros here, I take 2 zeros off of there. 80 divided by 2 is, well, 8 divided by 2 is 4, and I have the 1 0 left, if you want to think of it that way. So, $90,000 divided by 30. How many zeros am I going to cancel? Just 1. 9 divided by 3 is 3. How many zeros are left? 3. So I get 3,000. Actually, I'll make this a little easier on this. If I have 10,000 divided by 200, I can cancel my zeros. I cancel out 2 zeros. 1 doesn't divide by 2, does it? What I can do is this. Instead of just taking the 1, I'll take the 10. What's 10 divided by 2? 5. Now that 0 is used up, but I do still have 1 more. So it's 50. I'm not saying you have to do your estimating this way. I'm just giving you this as one example of doing it. Just like there's multiple ways of adding and subtracting and multiplying and dividing, there are multiple ways of estimating. Come up with a method that works for you that you can do quickly in your head. Because if it's not easy and if it doesn't work for you, you're not going to do it. So come up with something. You know, throughout the semester, you're going to see me do a lot of large calculations in my head fairly quickly. One of the reasons I can do that is I know several different ways to do each operation. You look at, sometimes you can look at the numbers, you can see that with certain numbers, one method is going to be a lot easier to do than another. Like one of the subtractions we did was something like 538 minus 297. I can very quickly look at that and say that this is going to be 241. The reason for that is using an estimation process along with my subtraction. Anybody curious how I can do that so quickly? I don't want to do it here. I don't want to waste time and confuse people. But it's a matter of rounding the numbers off and then bringing the other digits in the end. Okay, we still have division to talk about. The reason I did all that before division is the one operation that has been altered and changed the most from what it really is. What most of you were taught as long division is an extreme shortcut of the real process. Before we do that, I want to review a little bit, since division and multiplication are so closely linked. I want to review a little bit of what a really basic multiplication is. Most of us now know 5 times 3 is 15. But if you go way back to like first grade, when you first started multiplying, before you memorized your multiplication tables and you just knew that 5 times 3 is 15, how did you figure that out? Perfect. That's saying take 5 3 times, or 3 5s added together. 5 plus 5 plus 5 is 15. Multiplication, the definition of multiplication is repeated addition. Now, I had mentioned earlier that multiplication and division are the same operation, just one is going forward and one's going in reverse. So if multiplication is repeated addition, it makes sense that division would be repeated subtraction. 24 divided by 8 is asking, how many times can I subtract 8 from 24? So I would do 24, I can subtract 8 once, gives me 16, so that's once. I subtract 8 another time, I'm left with 8, that's twice. I subtract 8 again, I'm at 0, that's 3 times. 24 divided by 8 equals 3 because I can subtract 8 from 24 3 times. By the way, this also explains our remainder system. Let's say I have 30 divided by 7. I can subtract 7 from 30, gives me 23. That's once. Subtract 7 from 23 gives me 16. That's twice. Can I subtract 7 again? Yep, what do I get? 9, so that's 3 times. Can I subtract it again? Yep, I get 2. That's 4 times. Can I subtract it again? Not unless we're going negative, can I? So, 30 divided by 7 is 4 with a remainder of 2 because I can subtract 7 from 30 4 times with 2 left over. So now let's get on to long division. Let's take something like 68,592 divided by 21. Now, I just said that division was repeated subtraction. However, I'm not about to start subtracting 21 from 68,000. We don't have that kind of time. But what if there was a way to make it quicker? Like if I had, well, let's say I was doing like 31 divided by 2. Instead of subtracting 2, I could subtract 20. What did I just do there? I subtracted the 2 10 times, right? I subtracted a big bunch. I subtracted a bundle of 10 2s all at once. Long division is based on that concept. Instead of starting subtracting 21 and doing 21 over and over again, I'm going to subtract a large bundle of 21s. So the first question is, how big of a bundle? Well, I get that off of the number I'm dividing. The first digit, the 6, is in what place value? 10,000s. So 10,000 times 21 is 210,000. Can I subtract that, or is it too big? It's too big. So what that's telling me is I cannot subtract a bundle of 10,000 21s. It's too big. So what's my next step down? 1,000 would be my next place value. So 1,000 times 21 is 21,000. Can I subtract that? Yes, I can. Now, technically, I should do this. and subtract it again. And then subtract it again, right? What I just did was I subtracted 21, 1,000, 2,000, 3,000 times. Make sense? Now, the way we shorten that is we just do this. 21,000 times 3 is 63,000. So we could have just subtracted 63,000. That would be 3 bundles of 1,021s or 3,000 times. What's my next place value down? 100, right? 100 times 21 is 2,100. Can I subtract that from the 6,500? Sure can. Now I'm going to do this. If I multiply that by 3, that's 6,300. I can subtract this bundle 3 times. That's the same as subtracting the 2,100 3 times. I'm just saving some space here. I get 2, 9, and 2. So what I did is I subtracted how many bundles of 100? 3. So 3 times 100. I just subtracted 21 300 more times. Next place value is 10. 10 times 21 is 210. Can I subtract that from what's left? Yes. In fact, I can only do it once. So I just subtracted it 1 bundle of 10, or just 10 more times. My last place value is going to be the ones. 1 times 21 is just 21. I didn't really have to do that, but I wanted to stay consistent. Can I subtract that from what's left? Yeah. Once again, it'd be 3 times. That'd be 63. Leaves me with 19. So 1 times 3 was just 3 more times. So I just subtracted this 3,313 times with a remainder of 19. Now you might be looking at that thinking, that looks absolutely nothing like the process of long division I was taught. But I'm going to argue that it is exactly what you were taught. What we did over here is we looked at the place value of this first number, right? The way you were taught was you look at that first number. Does 21 go into 6? No, it doesn't, right? So we leave that blank up above there. That's the same as what we just did here. Can't take it out 10,000 times, so we move it to the next place. We move over to the next place, the 8. Does 21 go into 68? Yes. It goes how many times? 3. 3 times 21 is 63. Now, like we said here, we could have done this times 3 and did 63,000 here. 68 minus 63 is 5. Notice that's exactly what we did here, only we left out the zeros here. And what did I do wrong there? I subtracted wrong up here, didn't I? That should have been 7. Oh well, you guys get the point. I screwed that up, but it's all there. The process of long division we were taught is the same as this process. We're just leaving all the zeros out and shortening it up and going 1 digit at a time. Now, since I screwed that up, that's a good segue. Long division is the one process I try to avoid doing by hand, just because there's so many steps that you can mess up. But anyway, if you're going to do this on the calculator, I would still expect that you look at this and say, hey, that's about 70,000. This is about 20. Cancel out a 0. 70 divided by 2 is 35. 2 zeros left. I'm expecting an answer around 3,500. This actually is going to come out to be 32 something. We're not going to worry about it. On your calculator, of course, it won't give you a remainder. We know that's wrong. It won't give you a remainder. It's just going to give you a decimal. When we get to that point, we'll look at if you need to get the remainder, we'll figure out how you can get that remainder out of it. Sorry I screwed that one up. It's the first day. Okay, any questions? When we take a quiz on this, which will probably be next week Monday, will be your first quiz, just so you're ready. There will be, like I said, four to six questions where I ask you to do them without the calculator. when you get to the part where you can use the calculator, if you want to go back and double check them with your calculator, that's fine by me. Just make sure that you show your work and you show how you lined them up. Even if you have accommodations, you can use your calculator. Make sure you still line them up and show me how you line them up to do the operations. We're a little early today because I got talking a little too fast. Sorry about that. Normally in class, I know most of you didn't have to take notes today, so if I get talking too fast, don't be afraid to ask me to slow down. I will do my best. Late in the day, I start talking faster for some reason. Anyway, the way this class is normally set up, it's a 3-credit class, or 2-credit class, but we meet 3 hours a week. So it is designed to be 2 hours of lecture and presentation every week and about 1 hour of homework time. So I usually, this is a little earlier than I would normally like to be, but normally somewhere between 4:05 and 4:10, I will be ending the lecture and giving you guys homework. Now today, since we had a 2-hour class to start it out, there is homework to do. Your homework is out of your book, pages 8 through 10, problems 1 through 70, the odds. By odds, that's just 1, 3, 5, 9, and so on. 1, 3, 5, 7, 9, so on. The reason why I assign the odds, for a couple reasons. One is so it's not such a large assignment. 2 is, in a couple minutes here, I'm going to hand out a packet that has the answers for all the odd-numbered questions. So I do expect you to look over your own homework and check your own answers. Couple reasons for that is, the biggest one is I don't want you to do your whole assignment, do it wrong, and then you've developed a bad habit. If you're doing something wrong, I want you to catch it right away so you can stop doing it and do it right before you get that wrong process stuck in your head. So I would suggest you do a few problems, check them over, and then keep going if you're doing them well. If you're not, if you got them wrong, figure it out. Otherwise, that's where we'll start our next class, is answering questions on what you did wrong and seeing if I can help you figure out what you did wrong. As you're doing these, if you get the first few right and they seem really easy, especially in these first several assignments, if they seem really easy, as I said, I don't want you sitting there doing busy work, doing stuff you already know. If you do 1 and maybe 3 and they seem really easy, go ahead and skip up to maybe problem 11 or 13 or whatever. Go to the more difficult ones or skip to the next little section in the homework. Go to the more difficult ones and challenge yourself. If they're really easy, some of you may only have to do a handful of these homework problems and you'll feel ready to take a quiz on it. If not, go back and do more. So I'm leaving, we're adults now, so I'm leaving that part up to you to make sure you do enough that you're prepared for a quiz. Okay, so I'm going to leave it at that. You have the last 17 or 18 minutes here to get started on your homework. I'm going to pass out the packet for you with the answers in it, and I'll be here to answer any questions if you have them.